The Hubble Space Telescope was launched in 1990 and has revolutionized our understanding of the universe for more than 3 decades. The importance of Hubble and his discoveries cannot be overstated, and it may have revealed more about our universe than any other telescope in history. While Hubble was the most powerful space telescope for many years, the newly launched James Webb Telescope is even more powerful, and it is expected to build on Hubble's discoveries and reveal more about the universe. With Hubble's successor now in space and making discoveries, it's time to reflect on some of Hubble's most important discoveries. Here are the Hubble's 10 most significant discoveries. 10. Origin of gamma-ray bursts. A gamma-ray burst is a large burst of the most energetic form of light, gamma radiation. The first gamma-ray burst was discovered in 1967, but it wasn't until 2013 that scientists discovered what caused them. Most gamma-ray bursts last only a few seconds, making pinpointing their exact cause difficult. However, in 2013, the Hubble Space Telescope observed a gamma-ray burst as it occurred, revealing the cosmic event that caused the burst. A kilonova is an event that occurs when two neutron stars collide and explode. However, this is not the only cause of gamma-ray bursts. A star's gravitational collapse into a black hole is another cause. As a black hole devours a star's outer layers, massive beams of gamma radiation are emitted into space. 9. Planetary collisions. In 1994, telescopes were aimed at Jupiter after a large comet collided with the gas giant. On July 16, 1994, the comet Shoemaker-Levy 9 collided with Jupiter's atmosphere. While ground-based telescopes were able to observe the collision, Hubble had a much better view from space, and it was also the only telescope able to observe the collision in multiple wavelengths of light. Subsequent Hubble data revealed how collisions behave in our solar system, shedding light on how planets may have formed from asteroids, comets, and meteors colliding. 8. Discovering supermassive black holes. By the time Hubble was launched, the existence of black holes had already been largely established, but supermassive black holes remained a mystery to scientists. These titanic objects, which are nearly always found at the centers of enormous galaxies, can be many millions to billions of times more massive than the Sun. Astronomers postulated the existence of supermassive black holes prior to the launch of Hubble based on some observations, but until Hubble, no observatory was quite sophisticated enough to confirm them. Astronomers were able to prove the existence of supermassive black holes in some galaxies because to Hubble's ability to determine the orbital speed of stars found in galactic centers. 7. How solar systems form. Astronomers have argued about the origin of solar systems for many years. They depended on models because telescopes were not developed enough to look for solar systems that were emerging. Then Hubble appeared. Hubble's immense power enabled it to gaze deeply inside stellar nurseries and observe freshly born stars in exquisite detail. Hubble also saw enormous disks of material encircling newborn stars in addition to stars. The regions surrounding young stars where planets originate are known as protoplanetary disks. Hubble's discovery of the origin of solar systems contributed to advances in the study of the planets. It's interesting to note that the Orion Nebula included the majority of the protoplanetary disks that Hubble had discovered. 6. Confirmed age of the universe. Prior to Hubble's launch, it had been estimated that the universe was roughly 14 billion years old, but Hubble's ability to observe farther than any other telescope in history allowed for the formal confirmation of this estimate. Hubble's ability to calculate the distances to some of the farthest galaxies allowed astronomers to determine that the universe is roughly 13.7 billion years old. In addition, Hubble gave astronomers the ability to gauge the universe's rate of expansion, which allowed them to turn back time and establish that the cosmos is roughly 13.7 billion years old. 5. Exoplanet atmospheres. Hubble was the first observatory to ever investigate an extrasolar planet's atmosphere and ascertain part of its chemical makeup in 2001. This was accomplished through Hubble's analysis of the light entering the planet's atmosphere, which produced a spectrum that could be examined to identify the composition. The planet itself is a hot Jupiter 150 light-years away, known as Osiris. Scientists declared in 2001 that Hubble had discovered sodium in the atmosphere of Osiris after examining the data. It has now become the norm when examining the atmospheres of exoplanets after Hubble demonstrated that planetary atmospheres could be studied in this manner. 4. Evolution of the stars. For many years, Hubble was the most powerful telescope in use. It transformed our understanding of nearly every aspect of the universe. The evolution of the stars was one of these aspects. Hubble can see stars and star clusters in great detail, allowing astronomers to study how stars form, live, and die. Hubble has also observed multiple generations of stars, allowing astronomers to calculate the overall life cycle of each type of star. Astronomers can learn about how different stars evolve over time by observing multiple stars of varying ages. 3. Evolution of galaxies. For many years, Hubble was able to see further than any other telescope. Because light travels at the speed of light, whenever we look out into space, we are also looking into the past. The greater the power of a telescope, the further away and back in time it can see. Hubble can see billions of years into the past and can observe what are possibly some of the universe's youngest galaxies. Observing multiple galaxies from different time periods, like Hubble's observations with stars, has allowed astronomers to gain a better understanding of how these vast collections of stars form and evolve. No other telescope has observed galaxies in the same detail as Hubble, but that is expected to change with the James Webb Telescope. 2. Finding dark matter. Dark matter is one of physics and astronomy's greatest mysteries. Its existence can be deduced from its gravitational interaction with visible matter. While the existence of dark matter was predicted in the 1930s, the Hubble Space Telescope observed it in unprecedented detail. Hubble observed multiple lines of evidence for the existence of dark matter, including galaxies' rotation, the mass of galaxy clusters, and gravitational lensing. If anyone had any doubts about the existence of dark matter, Hubble likely dispelled them by discovering that dark matter is abundant throughout the universe. 1. Dark energy and the acceleration of space. The Hubble Space Telescope was named after astronomer Edwin Hubble, who discovered the existence of other galaxies in 1924. Edwin Hubble, on the other hand, discovered that the universe is expanding. Almost every galaxy in the universe is racing away from us at breakneck speed. For years, astronomers predicted that the universe's expansion rate was slowing due to the inward pull of gravity. The expansion of space would eventually slow. However, in 1999, two teams of astronomers using the Hubble telescope discovered that space is not slowing down, but rather speeding up. Not only was space expanding at a rapid pace, but it was also accelerating. Space must contain a form of energy that causes it to expand in order for it to accelerate. This energy was dubbed dark energy, and it is possibly as mysterious as, if not more so than, dark matter.